Okay, let's talk about slopes. So before we even get into an equation, we have to think about the different types of slopes. If you have a line that's increasing like this, we say this type of line has a positive slope. If you have a line that's decreasing like that, we say this type of line has a negative slope. If you have a horizontal line, we say this type of line has a zero slope. And if you have a vertical line, we say this type of line has an undefined slope. In terms of real world example, if you're going up a hill, you can say that has a positive slope. If you're going downhill, it has a negative slope. If you're on a flat surface, it has no slope. And if you have a vertical wall, it has an undefined slope. Now let's take a look at this example. We have a line and 2 points on the line, A at 1, 2, and B at 4, 4. Well, how do we determine the slope of this line? The slope of the line is essentially the rise divided by the run. But what is a rise and what is a run? The rise is essentially the change in the y-axis, so change in the vertical direction. How high or how low you have to go in order to go from one point to the other. And the run is a change in the x direction, a change in the horizontal direction, whether you're going left or right. So we can write that mathematically as delta y divided by delta x. And delta, this triangle, is essentially change. This is what change means. And we can rewrite that as the change in y, which is y2 minus y1, meaning if you have 2 points, you take the difference in their y values divided by the difference in their x values, x2 minus x1. So we have 2 points here, and I can label what x1 and y1 are. So I can call this x1. That means I have to call this y1. Let me rewrite that. y1. And this is x2, and I can call this y2. If I wanted to, I could have called this x1, and I could have called this y1, and I could have called this x2, and I could have called this y2. It doesn't matter as long as you keep them consistent. If this is x1, this has to be y1. You can't call this x1 and y2. You have to keep it as x1, y1. So now let's plug in the numbers. So change in y, so y2 is 2 minus y1, which is 4, divided by x2, which is 1, minus x1, which is 4. 2 minus 4 is negative 2, divided by 1 minus 4 is negative 3. Negative 2 over negative 3 gives us a positive slope of 2/3. And we know this has a positive slope because this is a line that's going up. It's increasing. So just based off of this table here, we know that the slope should have been positive. So that's one way you could have checked. If you would have gotten a negative number here, you know you did something wrong because we know the slope should have been positive. But now let's try to solve this by using the rise over run equation. Well, let's see. To go from 1 to 4, right, how much do I have to... Oh, I'm sorry. Let's start with y. To go from 2 to 4, how much do I have to rise? So to go from 2 to 4, my rise is going to be 2. I have to go up 2, right? So to go from 2 to 4, I have to go up 2. And to go from 1 to 4, how much do I have to run? I have to go over 3. Okay, so my rise here is 2, and my run is 3. So when you plug that into the equation, if slope is rise over run, the rise is 2, you can plug in 2, and the run here is 3, and you can still get 2/3, and that's the slope.